Bismillahirrahmanirrahim. Hello, my dear students. I hope you are all fine. I welcome you all in lecture series of past paper solutions of O-level mathematics related to linear inequalities in two variable. In today's lecture, we will discuss paper 2011 June session. In this year, two questions were asked from this topic. The first question is in paper 1 variant 2. This is question number 14, and this question says we have to solve the inequality 5y minus 3 greater than 3y plus 2. The first part is very easy. We will move variable terms on the same side. So by subtracting 3y or moving 3y here and constant on the other side, this gives us 5y minus 3y greater than 12 plus 3, and 5y minus 3y, this is equal to 2y greater than 15, and from here your y is greater than 15 by 2, or you can write y is greater than 7.5. In its B part, write down all the integers that satisfy the inequality. Firstly, we find the value of x from this inequality. So dividing the coefficient of x, that is 3, on both sides, we have minus 6 by 3 less than 3x by 3. This is less than or equal. This is less than 6 by 3. This is equal to minus 2 less than or equal to x, and x is less than 2. From this inequality, you can find the number of integers. The possible integers are x is equal to minus 2. The next one is x is equal to minus 1. Next is 0 and 1. 2 cannot be included here because this inequality has no equal sign here. So the possible integers are this, and it completes question number 14. The same year, second question number 15 was asked, and this question is about the shaded region. The question statement is the shaded region on the diagram. The shaded region on the diagram is represented by the three inequalities. One of these is, this is our first inequality, y greater than or equal to 3x minus 2. So, and we have to find, write down the other two inequalities. So firstly, we identify the associated equation of this inequality. Which of the line represent this equation? So firstly, we will write boundary line of given inequality is, boundary line also called associated equation. So you may write here associated equation of given inequality is, simply replace greater than or equal to sign with just equal sign. Y is equal to 3x minus 2. So now you have to identify which of the line represent y is equal to 3x minus 2. It cannot be this horizontal line, because horizontal line passes through variable, passes through 3, and the horizontal line, similarly vertical line, cannot involve both of the variables. So one of these two lines represent y is equal to 3x minus 2. So the easiest method is, you have to find its x and y intercept. How can you find x intercept? By putting x equal to 2. This gives us y is equal to minus 2. So its x intercept is, so this is y intercept, sorry. When you put x is equal to 0, your y is minus 2. This represents y intercept. Your y intercept is minus 2 here. See, so from here you can observe that which line cut y-axis at minus 2. this line. It means this line has a question y is equal to 3x minus 2 here. Otherwise, it is clear from here. If you compare this equation with y is equal to mx plus c is here y-intercept and y-intercept is minus 2 here. So there is no need to putting x is equal to 0 and y is equal to finding y is equal to minus 2 here. Our next target is to find the other two inequalities here. The first inequality is given by this horizontal line. Horizontal line y is equal to 3 gives the inequality gives inequality. Now you have to see whether the shaded region is above or below this line. Clearly the shaded region is below this line here. So below mean we will take less than or equal sign here, y less than or equal to 3. Further you have to notice that whether these lines are dotted or solid. The lines are solid here, so we will take here less than and equal both sign. If your lines are dotted, then you will take only less than sign. So the first inequality is y is less than or equal to 3. Now to find the last inequality that is attached with this line, you have to find what is its equation. So for this we will take just 2 points on this line. You can see here the first point is 0 0. You can take here this line passes through 0 0, and the second point on the grid is this is equal to x minus 1 and y is equal to 2 here. As last line passes through 0 0 and minus 1 2. So the gradient of this line is equal to gradient. You know the formula y2 minus y1 over x2 minus x1. We take this is my x1, this is my y1, and this is my x2, and this is my y2. Okay, now put y2 is 2, y1 is 0, and x2 is minus 1, x1 is 0. So your gradient is minus 2 here. Now using the slope point form, that is y minus y1 is equal to, suppose my gradient is m x minus x1. This is the slope point form of a line. What is y1? y1 is here 0, gradient is minus 2. What is x1? x1 is 0. So this become y is equal to minus 2x. It means this line has the equation y is equal to minus 2x. Now we have to find the opposite inequality here. Now you have to check whether the shaded region is below or above the line. Clearly this is my line. Shaded region is above the line, above this line here. So for above we will take greater than or equal sign. So last inequality. So corresponding inequality is corresponding inequality is y greater than or equal to minus 2x. Lastly, you can write sum of all of these inequality. So required inequalities are are y less than or equal to 3 and y greater than or equal to minus 2x, and the given inequality is y greater than or equal to 3x minus 2. This was given. and it completes the question. Next, just for your satisfaction, if you have a doubt whether we have correctly found this inequality or not, you will take any test point from here, from this region. A test point means any point that lies in this region. Suppose you take here this point. This point has a sorry. This point has okay. Sorry for disturbance. This point has a coordinate x0, y2. Now you have to put this point in the inequalities that you have found and check whether this point 0 2 satisfied all of these inequalities. When you put here here y is 2 and x is 0. When you put y here 2 less than or equal to 3, whether this inequality is true? Yes, this is true. When you put here this point y is 2 greater than equal to minus 2, what is x? X is 0. This become 2 greater than or equal to 0. Is this true? Yes, this is true. Now you have to put this point also in this inequality. 2 greater than equal to 3. What is x? X is 0 minus 2. 2 is greater than or equal to minus 2. Is this true? Yes, this is true. It means these points that we have chosen from region R satisfied all of these inequality. This shows that we have correctly found the inequalities. For example, if you mistakenly write this inequality as y greater than or equal to 3, and this is a point from the region R. Now, if you put this point here, 2 greater than equal to 3, is this true? No, this is not true, this is false. It means you have not correctly found this inequality. This should be less than or equal. So this method gives an idea to verify whether our inequalities are true, right, or wrong. So I hope now you have a clear understanding of this question. If you still you find any problem, you can message me. Inshallah, I will reply you. If you find this video helpful, kindly like, share, and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.